Hey, what's up, Algebra 1? It's Mr. Knight again. Once again, we're going to continue on with our Unit 1 review. So again, I'd like you to write just this part, and kind of ignore this because it'd be redundant to write it again. This is level 6, distance conversions. This is definitely one of the, I'd say it is the hardest level that you have to do in Unit 1, okay? And so to kind of help us get started, we're going to start off by multiplying fractions, do a quick review on that. And I'll show you this train track method, which is really good for converting distances. Also, if you haven't already, you should have this sheet, okay? This is your money conversions and your length conversions. We're going to be using the length conversions today for obvious reasons, okay? We're talking about distance. So we'll be referring to it. So multiplying fractions, I'm using just like regular symbols, okay? These are just some numbers, A, B, C, and D. And to multiply, when you're multiplying fractions, you're just going to multiply straight across, okay? So numerator times numerator, denominator times denominator. And so we get A times C on top and B times D on the bottom. If you ever see like variables written like this, it's assumed, because they're just chilling next to each other, that they're being multiplied, okay? Let's see an example of that. We're not going to work this one out yet, but you're just going to kind of see the idea. Right now, all we got to do, if we're multiplying fractions, we go straight across. So 4 times 3 is 12, and 7 times 5 is 35, and that's it. Okay, that is multiplying fractions. We should hopefully know how to do that, but again, I just want to make sure. Okay. Now here's a cool little trick. You can cancel numbers out before multiplying. All right. So if you have something like this, right? Again, I'm using A, B, and C. But this time, I have my A in the numerator and my A in the denominator. When I go to multiply these guys, I'm going to get A times C over A times B. Well, if I have something divided by itself, say like 3 divided by 3, they cancel out to 1, right? So if you notice that these guys are diagonal, like they're the same number, then you can go ahead and you can actually cancel those bad boys out, and you're just going to be left with C over B when everything is said and done, okay? The A's will cancel out to 1. 1 times C over B is still C over B, okay? So that's what I mean by canceling out. They're just going to 1. All right? So let's see a quick example of this. Okay? So I would like you guys to try this in class. This is 4/7 times 7 over 8. There's many different ways to actually do it. So go. And we're back. Okay. So if we're looking at this, again, I can do that same trick that I just showed you guys above, right? I have a 7 here, 7 here. Get rid of them. So I'm left with 4 over 8. 4 times 1 is 4. 8 times 1 is 8. And then, of course, we can actually reduce this to 1/2. Okay. But if you got 4 eighths, you got the idea. All right, so let's actually see the train track method. So this is skill 2. What is a train track method, and what does it have to do with converting distances? Okay, so the train tracks, it's just a way to organize our fractions that we multiply. So just like we did up here, that's really what the train tracks are setting out to do. Okay, so let's kind of see that. So if I have something like this, so these are my train tracks. Kinda, yeah, they kind of look like train tracks, I guess. But we have these little square quadrants for these guys. And to write that as fractions, that's the same thing as 3/2 times 8/5 times 5 over 2. Okay, that's all that means if you see this. Okay, so we're going to use that idea to kind of help us convert these distances. And so let's see it in this example. Okay, so we're going to use our distance chart and our train tracks to convert 12 feet to centimeters. Doesn't seem like that big of a task, okay? But it actually can be tricky if you're disorganized, which is why we do the train tracks. So let's look at these guys, okay? So again, I'm going to use my sheet, and the sheet is going to help me figure this problem out, okay? As soon as I find the rest of my pages, oh hey, it's hiding behind here, okay? So this is, I'm going to give you guys steps for conversion, okay? We're still converting 12 feet to centimeters. Sorry. We're still converting 12 feet to centimeters, but we're going to go step by step with this problem. I'll show you another example without the steps, okay, to see the process. I'm going to have you guys try one, right? So the first thing we got to do is we need to write down the known facts to get from one measurement to the next using the chart, okay? So basically what I mean by the facts is, if you look at our chart, we have facts written for both systems. We got our imperial system and our metric system, and then we also have the imperial to metric system. This 1 foot equals 12 inches, that is a fact. So what we want to do is we kind of want to write down our facts that'll help us get from feet to centimeters, right? So we're going from 12 feet to centimeters in this case. Well, if we're looking at our chart, there's no clear way to go from feet to centimeters easy. So we got to kind of like pick and choose effectively what we're going to do. Well, if I'm going from feet to centimeters, I need something that I can put feet to what in order to get centimeters. Okay, so for example, if I'm looking at this, I know 1 foot's equal to 12 inches. Okay, and then if I look, oh, I see 1 inch is equal to 2.54 centimeters. I can see that 1 inch equals 2.54 centimeters. So I'm going to write those guys down, okay? Because those, so 1 foot equals 12 inches, and I also know that 1 inch equals 2.54 centimeters. And now, I don't need this sheet anymore. We're good. We're done. We wrote down our facts. The second thing we're going to do is we're going to create our train tracks, starting with our original measurement. Here was our original measurement. It was 12 feet. And this is how you set it up every single time. You take whatever you had, what you're starting with the units, so you write 12 feet on top, and you put it over 1. Every single time. If you have 303 inches, 303 inches goes up here over 1. Okay? Include the unit. Keep the feet, keep the inches. Okay? And so, to continue our tracks, we're going to use the facts in step 1, these guys we wrote down, to build the rest of the tracks. Write the same units diagonally so they cancel. We're going to talk about that a little bit more in a little bit and see what that looks like, okay? But we're going to use these guys to fill in the rest. So I can go from feet to inches, and then I can go from inches to centimeters. So that's my game plan. We already have it with the facts. So to set this up, this guy is the next track. So now it's all about what goes on top and what goes on the bottom. So I'm actually going to set it up like this. 12 inches on top and 1 foot right here. Cool. And that one's done. And now I look at my next one, right? 1 inch equals 2.54 centimeters. Again, which one goes on top, which one goes on the bottom? So my inches are actually going to go on the bottom. 1 inch, and this will be 2.54 centimeters. Now, why am I writing like that? Well, I said, write the same units diagonally so they cancel. I'm writing, as I showed you guys with your fractions. That's why I showed you guys this. Because if I have something that's in the numerator and the denominator like this, and they're diagonal, I can cancel them out to 1. Well, that's what my units are doing. This is why I wrote them the way I did. Because my feet are going to cancel, and likewise my inches will cancel. So I'm only going to be left in centimeters, and I'm going feet to centimeters. So I want to be in centimeters, so that is the idea. That's how you get them to cancel. And now, our final step is multiply across after canceling out the like units, right? So this is 12 over 1 times 12 over 1 times 2.54 centimeters over 1. Right? We're going to end in centimeters. So now, like I multiplied fractions before, I go right across, right? Well, we know 1 times 1 times 1 is 1. Anything over 1 is just itself, so I don't even need to worry about the bottom. It's all 1s. But the top, this is where I might want to bring out my calculator and kind of help myself out a little bit. I know 12 times 12 is 144, and then I'm going to multiply that by 2.54. And I get 365.76 centimeters. So that means that 12 feet is the same as 365.76 centimeters, and that makes sense. Centimeters are a lot smaller than what a foot would be, which would be like from here to here. I'm getting a lot more of those over that same foot, so if I have 12 of these guys, then I'm going to need a lot more centimeters, okay? So that's kind of how you can reason through some of these problems and kind of make sure when you get an answer, it's actually a reasonable answer, okay? So now we're going to actually see it again. Okay, we're going to see it again. So we are going to try this problem right here. We are going to convert 430 meters to yards. This time we're going to round to the nearest tenth of a yard. Okay? So step one, again, using my notes. Step one, write down the known facts. Okay? What are the facts, man? Lay them out for me. Okay? Well, we're going from meters to yards. That's kind of our game plan, right? That's what we want to do. So now let's start seeing what facts we're going to actually need. Again, there's no clean way to go from meters to yards. Okay? But there is a way. But here's our meters right here. Okay, well, we have meters that are equal to decimeters, centimeters. Well, if we're going meters to yards, we're definitely jumping systems. So I'm actually going to pay attention to these two right here, right? Well, again, I showed in the last one that inches and centimeters are related. So here's my centimeters. And I know with my meters, hey, 1 meter is equal to 100 centimeters. So let's write that down, okay? 1 meter is equal to 100 centimeters. And then from centimeters, I know that there's 2.54 centimeters for every inch. 2.54 centimeters equals an inch. Alright, and now I'm in inches, okay? So now I want to go from inches to yards. Well, it looks like yards is in feet, but we know that feet and inches are related. Well, that's good. So we know that 12 inches are equal to 1 foot. And then we also finally know that 3 feet equal 1 yard. That was a lot. But now that we have the facts, guys, I don't need this anymore. I'm good. Step 2, start creating my tracks. Create my first track. What's my first track going to be? It's going to be whatever my starting amount is. Okay, so 430 meters over 1. Okay, now I got to fill in the rest of it using these facts right here. Using these facts. So let's just go down the list, right? Again, 1 meter is equal to 100 centimeters. How do I write that? Well, I need to write them so that the units will cancel out. So these meters will cancel out. Okay? And so that one's done. Now I move on to this one. Alright, once again, 2.54 centimeters equals 1 inch. My centimeters are going to go on the bottom now, so they cancel. And that's for 1 inch. Continue on. Let's extend this train track. We're getting a little thick here, okay? Now we have 12 inches, 1 feet. Again, 12 inches goes here, 1 foot goes here. And then finally our last track, and this is why it's so good to have train tracks. It keeps everything nice, clean, and organized. 3 feet for every 1 yard. So my feet go on the bottom, and now my yard goes on top. And now what's going to happen is, again, every diagonal thing that's the same will cancel. The meters cancel, the centimeters cancel, the inches, the feet. So we're just left in yards. That's our only unit. We wanted to go from meters to yards. Okay? Now we just multiply. And now it's good we did this because not everything on the bottom is 1 now. So we can't just ignore it. So I actually have to write it out. 430 over 1 times 100 over 1 times 1 over 2.54 times 1 over 12 times 1 yard over 3. Okay? So let's multiply the top straight across. Okay, again, use your calculator. Help yourself. 430 times 100 times 1 times 1 times 1. I get 43,000 on top. Now on the bottom, I get 1 times 1 times 2.54. 2.54 times 12 times 3. And I get 91.44 on the bottom. I actually forgot something on top. I forgot my yards, right? That was still on top. And now we have this weird looking guy. But we know how to convert that fraction to a decimal. How do we do it? Once again, level 1, good old reliable, the building block. We divide the top by the bottom. 43,000 divided by 91.44. I get that absolutely hideous, absolutely atrocious, every adjective you can think of number. I'm not going to write, well, I am going to write the whole thing. Who am I kidding? I'm going to write the whole thing, okay? But I wanted to round to the nearest tenth, right? We wanted to round to the nearest tenth. So my tenth spot's right here. I look to the number to the right. That's 5 or larger, so this guy goes up to 3. So my final answer is 470.3 yards. Who would have thought? Not me. But the math doesn't lie. The process is the same. So this is what I'd like us to do now. Okay? I would like you to look over this and try the homework problems. Okay? What we're going to do in class, because what I'm going to essentially do is I'm going to assign this video on Wednesday. And so if you're in the Thursday group, you're going to have a chance to do some more practice in class. We're going to watch the video. Okay? But for right now, if you are in class, whether it's Wednesday or Thursday, this is the you try problem. Okay? I want you to convert. Let's do 212. Let's do 212. Let's do decimeters. Whoa, decimeters to inches. Okay, and I want you to round to the nearest. Let's do the 100th of an inch. Okay, once you do that, the video is over. Please look over my train track method and try to familiarize yourself with it. I will see you Wednesday or Thursday so we can get more practice in class. Go on this problem, or it's a goodbye if you're not in class.